Okay, so let me fix my little video here. Okay, so looking at this one right here, this is the graph that we just looked at before. This is the graph of f of x equals e to the x, and we looked at trying to calculate what the instantaneous slope was at 1, and we're going to say, well, what if I wanted to find it at, at 0, at 1, or at 1.5, or at 2, or at 3, or whatever the case may be. That's where this is going, right? So we're going to say, let there be some point x. We're just going to say x. And what's the output of that function? E to the x. Okay? And then there is some point that is in front of that. Right? It's further to the right, we're going to say. We'll call this pink point. And pink point is x plus some amount, right? It's some amount ahead of it, so it must be plus some amount. So it's x plus h, which means that the output of this function is e to the x plus h. This is just plugged in. So what would the slope between x e to the x and x plus h, e to the x plus h, look like? Well, the slope is going to be e to the x plus h minus e to the x over x plus h minus x. Okay, well, let's simplify that, and we're going to say, let's let the limit as h approaches 0, because I want the distance between these 2 points to be basically nothing, and that'll give me the instantaneous slope between any 2 points. Okay, so the denominator is going to just simplify to h. And then the numerator, do you guys see that there's an e to the x times e to the h? It can be written like that. These two things are the same. Minus e to the x, right? Let's simplify that one more time. Let's factor out an e to the x at the numerator. E to the x, and then this part of that is going to become e to the h, and this part is going to become minus 1 all over h. Well, weird that we would have just spent all that time going over this right here, right? So all of this can be replaced with a 1. Awesome. E. So all of this simplifies to e to the x times 1, which is just e to the x. So we can say what we just said here is that the slope between some point and another point can be expressed by this function. And the distance between those 2 points can be represented by h. Okay. So as h approaches 0, the distance between those 2 points approaches 0. So what we just did there is we took all of this, and we said there's no difference now, basically no difference, between the first point and the second point. So what we calculated was the instantaneous slope, or the slope at any one point. Well, I don't think I'm spelling that right, but you get the idea. The instantaneous slope at any point can be calculated by plugging in x into e to the x. Okay, I'll show you just briefly and then we'll be done. That means that at 2, from our table before, we know that f of 2 equals equals 7 point, I should plug it in here for you one more time. 389, so 7.39. Okay, so when I plug in 2, I get 7.39. The instantaneous slope, at 2 is also that number. Or if I were to plug in 1, I would get that the slope here is e. So this is one of the special features of the function e to the x. It's special because the slope at any point along this line is actually e to the x. So here it's e to the 2. Here it's e to the 1.5. Here it's e to the 1. Here it's e to the 1/2. Here it's e to the 0, right? What is the slope of e to the x at 0? It's 1. What's the output of e to the 0? 1. So that's one of the cool features of f of x equals e to the x. So something neat to remember about e to the x. In class 5.3 mostly focuses on this formula, on how to use it and how to apply it. So we will go over practice of that in class, but I do expect that you understand this. This is your very first time doing a little baby derivative. Good job, guys. Woo!